Hi class, this is the third lecture or video of the week, our first full week back to class. Um, so in this video, we will go over some terminology, a little bit about the different places that carbon is stored, the movement of carbon between those places, or just kind of still in the introductory materials. We'll dive a little bit deeper as this class goes on. So to accompany basically your reading should kind of go over a lot of what I'm doing right now. So the first is the terminology of the carbon cycle. The first one's going to be reservoirs, which you can think of as a place where carbon is stored. I did go over this a little bit, I think, in the last video, but an example would be the atmosphere, ocean, soil, sediments, things like that. Now, the pools are very closely related to reservoirs, and I've honestly heard them interchangeably. But technically, a pool is going to be a reservoir which has the capacity to accumulate or release carbon. So there is going to be some movement there, or flux, between the pools. Speaking of flux, then the flux is going to be a flow of energy of materials from one pool to another. You can think of that as the movement of carbon. Let's see. With flux, we're usually speaking of a quantity or a concentration, how much of it is being moved from one pool to the next. And the last one is going to be the turnover or residence time. This is going to be the average time that an element spends in a pool. You can think of this as being kind of like different types of food in your refrigerator. So something that you might like a lot is going to have a shorter residence time, like ice cream in your refrigerator, than something that you may not like as much. Maybe you don't like Brussels sprouts, then that's going to have a really long residence time in your refrigerator because you're definitely going to choose it last, right? So that's going to be kind of the idea of residence time, and that kind of goes into the whole idea of time scales, because different pools have different residence times, and so therefore, carbon will spend more time in one place versus another. Okay, so to go into this next slide, this is the land and ocean interactions of the carbon cycle. You can see that there are definitely carbon pools on this I want to say diagram, I guess, here, this picture here. So, different things that it's kind of showing you is some biological, I'm going to start in the ocean here, some biological processes. It's going to show you the biological pump, which are going to be like photosynthesis and respiration. There's definitely going to be some burial of carbon in sediments, sinking partial particles from the surface ocean into the deep ocean. Notice that they're distinguishing the difference, but there's a distinguishing factor between the two because we kind of do think of them differently. Let's see, CO2 is definitely going to be absorbed from the atmosphere. There's also going to be some hydrothermal vents that would possibly have some CO2 that comes out of them from the middle of the ocean here. And also plankton use carbon to make their shells, these little critters. So all of these things are going to be, I guess, like interactions of the carbon cycle within the ocean. Now, on the land, we also have photosynthesis and respiration, which make up the biological pump. These are pretty much the same, but they're naming them a little bit differently here. They do show fossil fuel burning here. This is anthropogenic. Also, some melting permafrost. If there was some sort of permafrost over here melting, that would also be something. Let's see, CO2 stored in ice. There's also volcanoes that will release carbon into the atmosphere. Erosion of soil. Also rock. Carbon stored in rock. Erosion of that as well would be another way that you'd see an interaction of the carbon cycle. And then wildfires, I think they're trying to show that right here, but wildfires, both naturally and anthropogenically, would also be a way that there's an interaction of the carbon cycle with land. So this, between land and the atmosphere, I guess I should say. So you can see this schematic shows you not just the pools or the reservoirs, but also some of the interactions between those pools and reservoirs with another one. So you will read more about this though. So, but it's nice to see, I think, a visual to go along with that. Okay, so this is going to be the distribution of carbon in the Earth's reservoirs, or the flows, between the planets and soil and the atmosphere. So going from the plants to the atmosphere, these are going to be things like respiration, deforestation, wildfires. These are all ways that carbon goes from the soil and into the atmosphere. Photosynthesis is going to be something that might bring it from the atmosphere down into the soil. Also, there's going to be some gas exchanges between the ocean and the atmosphere. So that's going to be another way that they're going to be kind of moving between the two. And then the coal, oil, and gas in the atmosphere, this is pretty much completely anthropogenic. So, but if you notice, if you look at it, the atmosphere actually is the smallest of the pools. We do talk about the atmosphere with respect to carbon a lot, I think because of climate change, but when we're talking about the carbon cycle in pools, the atmosphere is actually one of the smallest reservoirs of carbon. So, kind of interesting, I guess. Okay, and then this is actually going to show you the fluxes of carbon between, the atmosphere and the land and the ocean. So these ones over here, these are anthropogenic, the fire, cement, fossil fuels, land use, land sink. But if you take these kind of away and you just look at the natural ones, it does kind of appear somewhat balanced, which it is pretty balanced actually if you're not considering anthropogenic influences. So another interesting factor that you might notice here is that the ocean is actually taking up more than it's releasing. So that's kind of another thing. I'm just pointing these things out to you just in case, let's see, what else? Oh, the bulk of carbon is going to be in the rocks. So there's also a lot of carbon in the deep water, the deep ocean, but most of it is actually in rocks and sedimentary rock here. Let's see. Is there anything else I wanted to mention? I don't think so, but I just kind of want you guys to, I'll put the slide deck up on Canvas so you can kind of look at these, on your own and just kind of study them, because it is kind of interesting to see the different exchanges between these two, or between all of the different, I want to say pools or reservoirs. This is also something you'll be reading about a little bit further. I think it's in chapter 2 of Archer. It might be in chapter 1, though. You guys might be reading it this week. So, and we'll definitely go over the carbon cycle itself goes through a bunch of this as well when we go over that. I think we go over that next week. So, this is our last video, though. I do look forward to looking at you guys, or watching you guys' videos, your introductory videos. But I'm going to say goodbye for now, and I will see you next week.